Section 1.4 deals with solving quadratics. Quadratics are where we have x squared in here. The first way to solve a quadratic is just to take square roots. This works only if I just have an x squared term. If there's an x squared term and also an x to the first, we cannot do this. But on these first few, we can. So if I take the square root, remember, when you take the square root of both sides, you're going to get a plus or a minus. That's a big thing that students forget about. Square root of 60, then just like we've been doing, we're going to break down. So maybe you break it into 2 and a 30, 2 and a 15. 15 is 3 and 5. So since I have a pair of 2's, I can bring out the 2. The 3 times the 5 stays in the square root. Notice really I have two answers here, positive 2 root 15, negative 2 root 15. Most quadratics, we're going to get two answers. For number 2, I've got to do a little work first. So I'm going to add the 144 over. So x squared equals 144. Square root both sides. And remember, when I do that, I get a plus or a minus. Square root of 144 is nice and easy. It's 12. Now, since we've talked about I in complex numbers, for letter number 3, we can do this. We square root both sides. We know how to deal with that square root of a negative. We just bring out an I. If I break down 72, maybe I do a 36 and a 2. 36 breaks into a 6 and a 6. I don't have to break those down further because there's a pair. So this would be 6 root 2 I. And as I mentioned in the previous lesson, the I can go behind the square root or in front of it, either option. Remember though, we took the square root, so we still get a plus or a minus out in front. For number 4, definitely looks a little stranger, but I still can take the square root of both sides. It's just going to take a little more work afterwards. So if I square root both sides, I've got 2x minus 3. Still plus or minus. Root 7 I can't really do anything with. Notice though that x is not by itself yet. So I just have to keep working through this problem. I'm going to add 3 over. Now I can put it in front or behind the root. I'm going to put it out in front. This will be 2x equals 3 plus or minus root 7. Last step will be to divide by 2. So I get that x is 3 plus or minus root 7 all over 2. Again, that really is two answers. Number 15, it's just an x squared one again. So if I square root both sides, remember I'm going to get a plus or minus. The negative inside means I know I'm bringing out an I. Square root of 16 is 4, so plus or minus 4i. Number 6 is very similar to number 4 in that I'm going to take the square root. I know that gives me a plus or minus. So I have z plus 4 equals plus or minus. The square root of negative 4 would be 2i. I don't have the variable by itself quite yet, so I still need to subtract over 4. And I'm going to put the negative 4 out in front of the imaginary stuff. So it'll look something like that. Negative 4 plus or minus 2i. So those first 6 problems, we could take square roots. The big thing to remember was that there's always a plus or minus when we take a square root in an equation. Number 7 starts with problems that we can't just take the square root. This is where factoring comes into play, which you've been doing factoring since probably an Algebra 1 course. So hopefully some of this starts to come back as we go through it. I can't, again, don't write this down. I can't just say, oh, I'll take the square root of both sides or something like that, because I still have this x that's to the first power messing everything up. So instead, I have to try to factor this. Now, this type here, this type of called a quadratic trinomial, that has 3 terms, trinomial. If it has a leading 1, which this one does, there's really a 1 in front of the x squared. This is what I call X method. This is just a method I discovered. I like it. You don't have to use it, but you draw a big X. On the top of your X is going to be your A number times your C number. Remember that the numbers go A, B, C in a quadratic. The bottom of your X is going to be your B number. So for this particular problem, A times C is going to be 1 times negative 15. That's negative 15. The B number is negative 2. So negative 2 down here. Now, and this is the part you'll probably remember from a previous algebra course, I try to find 2 numbers that will multiply to negative 15 and add to negative 2. Multiply to negative 15, add to negative 2. The 2 numbers that work are negative 5 and 3. Those go on the sides of the X. Those numbers are going to go into my factors, and my factors are going to have an X in the beginning. And then the numbers I just found, the negative 5 and positive 3, they can go either order, does not matter. Oops, 3, not 2. By the way, you can check to make sure that you did this right, that you factored correctly by using FOIL. You can multiply them back together. Usually you can get to the point where you can do this in your head, but if I were to check this, first times first, x squared. Outers, 3x. Inners, negative 5x. Last, negative 15. That would turn into x squared minus 2x plus 15. Or sorry, minus 15. So you can always check your factoring to make sure it worked right. So I've done the hard work of this problem. I've got it factored. Now I'm going to use what's called the zero factor property. The logic here is if all of this highlighted stuff is actually just the number 0, 0 times who cares what's over here equals 0. So as long as one of the factors is 0, the whole thing is going to be 0. So here's the logic. If I make that factor equal 0, I'll get a right answer, which means x would be 5. I just add the 5 over. Likewise, if the other factor is 0, we're also good. So if x plus 3 was 0, which would mean x would be negative 3, we're also good. So that's the idea of the zero factor property. On number 8, I have to do a little bit of work to get this ready. I'm going to add over the 25. So this is going to be x squared minus 10x plus 25 equals 0. Looks like an X method problem. So again, you don't have to do this, but it's going to help you when we get to the more complicated problems that are coming up on number 9 and 10. A times C goes up top. So that's going to be 1. There's really a 1 out in front of that x squared. 1 times 25, 25. The B number goes on bottom, that's a negative 10. And then I say, what numbers multiply to 25, add to negative 10? That would be negative 5 and negative 5. Now, this is a special case. Since I got the same thing twice, I can write this as just x minus 5 squared. It's the same factor twice. But just like the previous problem, the same logic is going to apply. I want to make the factor 0. The number that would make this factor 0 would be positive 5. So I'd have 5 minus 5 squared. Will that be 0 squared? 0 squared is 0. It works. So those two problems, since they had a leading 1, the highest coefficient, or the leading coefficient, excuse me, was 1, those I could do with just what I call X method. If the leading coefficient is not the number 1, like on the next two problems, then I have to go to a little more complicated process that I call X box method. Now, you may have heard of factor by grouping. You may have heard of guess and check. Those are all methods that different teachers teach for this. I like X box. You do not have to do it my way, but it's a nice procedural way that works. It still starts off with X method. But notice, by the way, this is a 2, not a 1. So that's going to make things more complicated. So it still starts off with X method. A times C goes on top. So that'd be 2 times negative 36. That's negative 72. The B number, which is a negative 1, really, goes on bottom. I still do things like X method. I look for two numbers that multiply to negative 72 and add to negative 1. They would be negative 9 and positive 8. But now here's where things get trickier. I go from an X to a box. You're going to probably have to watch this a few times over to get the feel for what I'm doing. I'm basically going to split my original trinomial into 4 parts. Here's what I'm going to do. The first term is going to go in the first box, 2x squared. The last term, the negative 36, in the last box. But now I'm going to use the two numbers that I found and put them in the remaining 2 boxes. It does not matter which one goes where. And I'm going to hook the variable onto them. If you think about it, negative 9x, that's a 9, it's a terrible 9. Negative 9x plus 8x is negative 1x. So I really have the same thing, I just split it into 4 pieces. Now what I'm going to do is basically what the reverse of a Punnett square that you might have heard in like a bio class. I'm going to bring out the greatest common factor of this top row. The greatest common factor of 2x squared and 8x is 2x. I'm going to then do the same thing on this bottom row. I'm going to bring out the greatest common factor between negative 9x and negative 36. Now, another thing with this X box, the square next to the outside, if it's negative, I've got to bring the negative out. So since I've got a negative there on the 9, that means that I'm going to have to bring out a negative. And the greatest common factor would be negative 9. I'm going to do the same thing for the columns. I'm going to bring the GCF out above the first column. Between 2x squared and 9x, the only thing they have in common is an x. Now on the second column, since the 8 is positive, it's going to be a positive here. The greatest common factor between 8x and 36 is 4. And again, it's going to be a positive 4 because 8 was positive. These are now my factors. 2x minus 9, x plus 4. Now, that may have felt like a longer way to do this problem. Maybe you could have guessed and checked and got there, done a factor by grouping. It's just a different method that I've taught several times, and it seems to work for a lot of students. Again, it is not required that you use Xbox to do the factoring. Do it however you need to do it. Okay, I've gone through the hard part. Let's not forget to solve the problem. I have to use the zero factor property, so I need to ask myself, all right, if 2x minus 9 was 0, what would that mean x equals? Well, I would add 9, and I would divide by 2. So I'd have 9 halves for x. Separately, if x plus 4 equals 0, that would mean that x was negative 4. So finally, I've got my two answers, 9 halves and negative 4. For number 10, this is going to be another X box problem. I first, though, have to move over that 15. This is going to be 6x squared minus 13x minus 15. I still start with X method. A times C, which is going to be negative 90. B on the bottom, negative 13. I hunt for two numbers that multiply to negative 90 and add to negative 13. This one's a little trickier, but the numbers are negative 18 and 5. I now go from the X method to the box method. First term, first box. Last term, last box. The two numbers that I hunted for, the negative 18 and the 5, go in the remaining boxes. Attach the variable. Okay, now I start bringing out the GCF to the left of each row, which 6x squared and 5x, the GCF there would just be x. The bottom row, since that 18 has a negative on it, I know I'm bringing out a negative. So 18x and 15, they have a GCF of 3. Except again, I know it's going to be negative because the square next to it was negative. Then I do the same thing with the columns. 6x squared, negative 18x. GCF there is going to be 6x. And the second column, since 5 is positive, I know I'm going to be bringing out a positive. GCF of 5x and 15 is positive 5. So my factors are 6x plus 5, x minus 3. And again, I would set 6x plus 5 equal to 0, which would give me negative 5/6. I would set x minus 3 equal to 0, which would give me 3. So that covers taking square roots, which works some of the time, factoring and using the zero factor property, which still works only some of the time. Another method is called completing the square. Now, a lot of students don't like completing the square, but the quadratic formula, which we're going to learn in just a little bit, comes from completing the square. So it's actually very necessary. And there's a lot of times in higher math where completing the square is an important process. So I've got the steps here for completing the square. It's going to seem strange, but it does work. The first thing is, with completing the square, I have to have a leading coefficient of 1. So I'd have to divide everything by a to get a leading coefficient of 1. Fortunately, on this problem, there's already a leading coefficient of 1 in front of the x squared. So I don't have to worry about that. Next step, move the constant to the right side, okay? So that means it's going to be x squared plus 8x. I'm going to leave some space, and I'm going to subtract over the 14. So I moved the constant to the right side. Now, this is the weird thing. Off to the side, I take my b number, which is 8. I divide that by 2, and then I square it. So that's going to be 4 squared, or 16. That result gets added to both sides. I can't just add it to one side. I have to balance and add it to the other side. What you've done is you have created on the left side here a perfect square, meaning that should factor, if I did X method, it should factor into X something squared. So if you ask yourself what multiplies to 16 and adds to 8, again, if you did like a X method off to the side, it'd be 4 and 4. So this is x plus 4 squared. You have completed a square. You've built a perfect square on the left side. Over on the right side, I just have 2. Now this looks very similar. I'm going to scroll up to something like number 6 or number 4. I now just need to square root and get x by itself. So if I take the square root of both sides, remember that means I'm going to get a plus or minus. I'm just left with x plus 4 on the left side. Subtract over the 4. I have x equals negative 4 plus or minus root 2. I could not factor this problem. I had to do a different method because if I go back to the original problem, if I tried to do X method with this, for example, it'd be 14 on top, 8 on bottom. There's no two nice numbers that multiply to 14 and add to 8. So not everything can be factored, or at least nicely factored. So sometimes I have to resort to a different method. Okay, we're going to stop this video here. We're going to deal with quadratic formula on the next one.